This video is going to be an introductory video to Section 8.3 regarding matrices. So open your note packet to 8.3. The first thing is, what is a matrix? A matrix is an array of numbers in square brackets, and those numbers are called entries. And in a matrix you have rows and you have columns. Rows are the numbers that are going horizontally, columns are the numbers that are going vertically. And matrices are always described by their dimensions, and their dimensions are always rows by columns. So it would be like a 2 by 3 or a 4 by 1, a 2 by 6. And matrices are always denoted by a capital letter. So it'll say like capital A equals, and then it'll give you a matrix. So knowing that dimensions are rows by columns, let's take a look at these four matrices that we have here. So on your notes you have a first matrix that reads 3, 1, 7, 5, 0.8, and -5. This is a 2 by 3 matrix because there are 2 rows. That's how many horizontal rows there are, and then there are 3 columns, 1, 2, and 3. So it's a 2 by 3. The next one over has 5, 9, 4, and 0. There are 4 rows. That's how many numbers are going down, and then there is 1 column, and so that's a 4 by 1. The next one over you have -9, 4, 0, -5, 2, 4, and this is a 1 by 6 because there's only 1 row, but there are 6 columns. Even though there's only 1 number in each column, it's still considered a column. And then the last one we have what we call a square matrix. It's a 4 by 4. It's when the number of rows and the number of columns are equal. And you'll notice the entries that we have in a matrix can either be a decimal, they could be a negative number, a positive number, they could be 0, they could also be fractions, depending on what the situation is. So let's start with just saying that matrices can be equal if they, 1, have the exact same dimensions, and 2, all corresponding entries are the same. So the example that I have is XYZW is a 2 by 2 matrix, and it equals -24, 3, 0, -1/2. So if I just asked you what Y equals, you would tell me that Y equals 3. These two matrices have the same dimensions. They're both 2 by 2s, 2 rows, 2 columns, and the corresponding entries, so the entry that's in the same place, are equal. So since Y is in the top right and 3 is in the top right, that must mean Y equals 3. Scalar multiplication, this is like distribution but with matrices. So this is where you multiply all entries by the constant. So the example I have here is 4 times, and then I have a 2 by 2 matrix, 2, 5, -3, 0, and I just distribute that 4 to every entry. So 4 by 2 is 8, 4 by 5 is 20, 4 times -3 is -12, and 4 times 0 is 0. Matrix addition and subtraction. There are a couple of constraints that, or that's not the word I'm looking for, but there are a couple of things that have to happen in order for you to be able to add and subtract matrices. And the first one is that matrices must have the same dimensions. They have to be exactly equal. So you can add a 2 by 2 and a 2 by 2, but you could not add a 2 by 2 and a 2 by 3. And then once you do have the same dimensions, you just add or subtract all the corresponding entries. So the example I have here is I have 1, -5, 0, 2, plus -6, 5, 9, 1. These are both 2 by 2 matrices. So then I'm going to add the top left and the top left. So 1 plus a -6 is -5. -5 plus a 5 is 0. 0 plus 9 is 9, and 2 plus 1 is 3. And this also works for subtraction. Just remember that when you have the minus sign in the middle, if this had been a subtraction of 2 matrices, 1 minus a -6 would have turned into addition. So that would have been a 7 had I been subtracting these 2 matrices. And the last operation that you can do with matrices is matrix multiplication. Now this is a little different. You don't have to have the same dimensions. And so the constraints that we have with multiplication is, first of all, you can only do matrix multiplication if the number of columns in the first matrix equal the number of rows in the second matrix. And I'll show you an example of this in a minute. And then once you figure out if you can do multiplication because the columns in the first and the number of rows in the second match. Then the product dimensions are the outside numbers of the two dimensions of the matrices that you are multiplying together. So let me walk you through an example. So I have a matrix 2, 5, negative 3, 0, and 1, negative 4, 3, 2, 0, 5. So the first thing that we want to look at are the dimensions of each one of these. So this one right here is we have 2 rows and 2 columns, so it's a 2 by 2. The second one is a 2 rows and has 3 columns, so it's a 2 by 3. And so what we look at are the middle numbers. So if I were to line up the matrices, the 2 and the 2, those inside numbers, this is the columns of the first and the rows of the second, that's the same number, meaning I can multiply these two matrices together. The reason I have the first number and the last number highlighted is that the 2 and the 3, those outside numbers, are the dimensions of the product. So now if I were to switch these around, so if I put the order so that the 2 by 3 was first and then the 2 by 2 was second, I would not be able to multiply them together because then the inside numbers are 3 and 2. They don't match. So matrix multiplication is not commutative like multiplying numbers. So if I said 2 times 3 is the same thing as 3 times 2, that's true, that's commutative, but multiplying matrix A times B doesn't necessarily mean I can multiply matrix B times A. So order matters with matrix multiplication. Okay, so since we can multiply them, the first thing I am going to do is grab this little oval here. So I am going to circle the first row of my first column, and then I'm going to circle the first row of the first matrix. Then I am going to circle the first column of the second matrix. And what I'm going to do with matrix multiplication is I'm going to multiply the first entries together, multiply the second entries together, and then add those together. So I'm going to multiply 2 times 1, and I'm going to multiply 5 times 2, and I'm going to add those together. And so I'll show you my work here. 2 times 1 plus 5 times 2 is 12. Since I was dealing with the first row and the first column, I'm going to put my number in the first row and the first column, and there is the 12. I'm going to do the same thing now, but now I'm going to move over a column. So now I'm going to circle, I'm going to stay in this top row of my first matrix, but now I'm going to move over to the second column, and I'm going to do the same thing, the first entry times the first entry plus the second times the second. If I can circle this. So I'm going to do 2 times negative 4 plus 5 times 0, and that gives me negative 8. Since I'm in the first row and second column, my entry is going to go in the top middle, first row, second column. And then the last one is, since I still have another column, I can move over. I'm going to still stay in my top row of my first matrix. And then I'm going to slide over to the very last column of the second matrix and do the same thing. And so I'm going to multiply 2 times 3 and add that to 5 times 5, and I get 31. And since I'm still in the top row but I'm in the last column, that's where my product is going to go. And so I've just done the first row of my product matrix. So now when I move over, since I don't have any more columns, what do you think I'm going to do to get the bottom row of my product? That's right, I'm going to move down a row but then perform the same operation. So now I'm going to multiply this bottom row, the first entry with the first entry of the first column, and then add it to the second entry of the second entry. So go ahead and pause the video and try to find the bottom row of this matrix on your own using the same pattern that I used. And when you guys are all done, come back to the video and I will show you what the answers are. And after your work, you should have come up with negative 3, 12, negative 9 for the bottom row of your product matrix. And so now you are going to work on some practice problems with adding and subtracting matrices, scalar multiplication, and matrix multiplication. Tomorrow I will show you how to put a matrix into your calculator and how to check your work of doing this by hand by using your calculator to multiply the matrices for you.